sometime in the future, a space probe will plunge into a tunnel in space and time. One day, our universe will cool and die. Our only escape may be to risk a flight into a different universe. Perhaps the greatest question facing the human race is to discover where we came from and to find out what is our ultimate fate.
Every culture, every age has asked that question and tried to answer it.
It's one of the greatest adventures of the human mind to find out where we came from, where we are, and of course, in the end, where we're going.
Astronomy provides the basic information that each person needs to understand where he or she came from and where the human race is going.
Now, at the dawn of a new millennium, we are on the threshold of understanding how our universe began and how it will end. Cosmologists around the world are trying to unlock the origin and destiny of everything we see around us. One of this elite group is Bob Kirshner. He's on a journey to Cerro Tololo in Chile to measure if there's enough gravity to hold the universe together.
We've known for a long time that the universe is expanding and coasting along since the Big Bang. One of the questions has been how much gravity has been slowing down the expansion of the universe. Just like when you drive a car up a hill, you can slow down if you don't apply power because gravity's pulling back on you. We think that the expanding universe would be slowed down by the gravity, by all the stuff that's in the universe. One of the interesting things is that we've been able to do some work to try to measure that, and we found a surprising result. Not the one that we expected to find, but one that really turns the whole problem on its head.
Kirshner's team may have discovered answers that seal the fate of our universe. They've discovered that it's not just expanding. It's speeding up. Cosmologists now realize that to understand what the future may hold, they first have to unravel what happened at the beginning of the universe, at the start of time itself. In our daily lives, time is constant and dependable. It's almost impossible for us to imagine, but before the creation of the universe, there was no time.
We can trace back cosmic history to a stage when everything was very dense, very compressed, very hot. But the further we go back, conditions were so extreme that we can't really rely on any of our common sense intuitions. We can say that time, in the sense we understand it, didn't really exist before that.
So when did the clock start ticking? 12 billion years ago, there was absolutely nothing. No matter, no space, no time. We may never know how or why it happened, but a seething mass of energy smaller than an atom grew from nothing. You're inside the Big Bang, the birth of our universe, a violent fireball of unimaginable heat. For England's astronomer royal Martin Rees, understanding the Big Bang is the key to the universe.
Something that was literally originally only the size of a single atom or smaller, expanded to be large enough to encompass everything in our present universe.
Only the minutest fraction of a second had passed. But all of this was puny compared to what was about to happen. Propelled by a new surge of internal energy, the universe suddenly entered an incredible period of inflation. It expanded 100 trillion times to the size of a grapefruit. Einstein's famous equation, E equals mc squared, told us that energy and mass were interchangeable. It gave us the knowledge to build weapons of mass destruction and the knowledge to understand how our universe was born. When a nuclear bomb explodes, a tiny amount of matter is completely annihilated and converted into energy. But in the Big Bang, the exact opposite happened. Pure energy was converted into matter. Approaching a millionth of a second old, the universe was brimming with energy, so intense that it was spontaneously converted into lumps of matter, and its arch-rival, antimatter. A titanic battle ensued. Subatomic particles annihilated each other, blow for blow, particle for particle. When matter and antimatter meet, they mutually destruct. This is the most powerful release of energy known.
If our universe started off with equal amounts of matter and antimatter, all the atoms would annihilate with anti-atoms, and we'd end up with a universe consisting just of heat and radiation, but nothing from which we and the stars could have been made.
But somewhere in this tiny blazing inferno, the process was slightly imperfect. There was more matter than antimatter. At the end of the battle, matter had won, and the universe was far from empty. Every time a particle of antimatter had been annihilated, the energy was converted into radiation. And that radiation is right before our very eyes. Don't adjust your set. Hidden in the interference on a badly tuned TV set is the energy signal left from the first second of the universe. The discovery of the Big Bang was one of the greatest scientific discoveries of all time, even though it was an accident. This is the horn antenna at the Bell Research Labs in New Jersey. Its unusual funnel shape was designed to collect faint radio waves from early communication satellites. It was being used for an entirely different experiment when it detected something truly remarkable, a discovery that would win 2 American scientists the Nobel Prize.
When I visit the horn antenna, I'm always reminded of the days back in the 60s when Arno and I were using it seriously. You know, it's amazing to think about, just doing your experiment and discovering the beginning of the universe. But there it is.
In 1964, Bob Wilson and his colleague Arno Penzias were using the horn antenna to search for natural radio emissions from our own galaxy. But as soon as they switched their giant earpiece